Hello, how are you today? I'm Michael Fraser and I'm here to show you how my puzzle works. With this, I've designed two solutions of how the puzzle can be put together to be able to gain the extra 10% for the course. In my puzzle design, I designed a puzzle that demonstrates how I'm a T-shaped person through applying how my electrical engineering skills can be put to a simple problem of a puzzle. With this, I have my electrical engineering has put to use to be able to use and design a puzzle that allows electricity to flow in two different types of paths to be able to turn a fan on. I've tried to distract the user and engineer my own complexity through having useless information on the side that is nothing to do with feeling and only to do with the sight to try and distract and cause the sighted person to assume nonsense knowledge. As well as this, I have also spray painted the design black so that it makes them hard to see the feeling aspects for the component that makes it an engineered solution for a simple design for a non-sighted person. Going over my design, I have demonstrated how you can't see the paths of communication of how the electricity flow, as I've covered and used electrical paths that will transmit electricity. However, you can't see how the electricity will flow. I've ripped this one apart to try and show how there's metal in the center blocks to try and add a conducting path. Going into how I complete the design, I've used semiotic as my mode of communication rather than braille, so that everyone can try and complete the design even if they do not know braille. In this, I have demonstrated the two modes of communication through touch to having a tick and the correct path of how to put the puzzle together. That's one with a raised outdents and one with the indents. So looking into the design, I've engineered and used my own ability to using continuous feedback and taking a step back and looking at the design use cybernetics. So then to looking at this design, one of the aspects of this design was that all aspects have to be put in together to be able to turn on the fan. I've engineered these bumpers to be able to have a compression and depression, so then that when the last design is put in front then it actually pushes all the designs put together, which allows the electricity flow to the Trojan path once it's connected in the correct shape. I've also engineered added complexity through having numbers as well as the face coloured in the design to try and confuse the sighted person. I will now put the design together to show how one of the selected paths turns on the fan. So with this demonstrating how the paths go together, I have two blocks that are always glued together, and then I'll use the feeling of the outdented bits to try and put the path together. So I'm just matching up the outdented bits. And now I'll complete the puzzle, and the fan will not turn on till the last piece is put in place. So as soon as you put the last piece in, it turns on. This is demonstrating the path of how the raised edges are matching up to complete the path. You can see how the face and the numbers are distracting the user, and this is not the correct way. I will now demonstrate the second part of how the path can be put together to matching up the indent parts that are used through the feeling and are quite prominent for the non-sighted person to feel, that are actually coloured in black, which is hard for the sighted person to see, and they're actually getting distracted. As I said before, the fan will only turn on when the last block is put in place through my engineered design of these bumpers that compress the blocks to be able to put in and then decompress to be able to have the fan turn on when the last block is put in place. Showing the fan is in place now. With this is a second design as the path is now flowing through the touch parts that is going more on the outside, whereas previously it was going zigzagging up through the center. I will now show how we demonstrate how a sighted person has seeing complexity within this. Okay, I'm doing my first test with a non-sighted person with how to solve the puzzle. All the instructions that are given is to solve the puzzle to turn the fan on.
Okay, we've got flat surfaces. some raised sections on the side that feel like there's a tick there. Right, I've got a block that's got a raised section, so I'm going to assume that that is what I need to put in there. Another block with matching raised surface. Almost. So can't feel any other raised surfaces. So I'm going to fill in any gaps with those blocks.
Okay, as we can see, we got it first go and the fan is turned on. And you can feel the breeze coming.
And feel the breeze coming across the blocks.
So that was putting the connections together, which was with no confusion or no extraction from all these other assumptions that were made from a sighted person. Thank you. Okay, so this is take one of a sighted person trying to fix the puzzle. So you get started, you have to solve the puzzle. You have to put these blocks in this to be able to turn on a fan. So starting the puzzle, giving both candidates, it'll show you saying you have to put the puzzles in the frame to be able to turn on the fan. Where's the numbers? I don't know how the numbers are. Oh, you said look at the numbers. So they're sort of stuck in there. They're just starting blocks. So that's 8, 6, let's say 7. So as we see, when I fast forward to the sighted person completing the puzzle, he's getting a lot of distractions from the sights in front of him and the assumptions that he made based on his own heuristics of how he solved puzzles in the past. This is demonstrating how the complexities in the project is working effectively for the sighted person and making it really hard to navigate the complexity of how to solve the puzzle. After this leads to him completing the puzzle in a wrong way and not being able to turn the fan on. This therefore demonstrates the complexity within the simplicity, as how it demonstrated how the non-sighted person solved the puzzle straight away, and how the sighted person has failed to navigate the complexity of the project and really getting stuck up with the assumptions and the engineering complexity put into the project. In conclusion, it demonstrates how complexity is seen within simplicity and how simplicity is seen within complexity. This project gives a strong analogy of how cybernetics is used within a project to understand the interconnection between components, which gives a navigation of how to demonstrate complexity. With the sighted person going down the wrong path and assuming how to complete the puzzle, demonstrates how he needs to use critical reflection on how to solve the puzzle and take a step back and use his own cybernetics to try and look how the pieces are connected And why did it not work the first time? To try and look for the simple solution within complexity. Thank you.